Let's see another problem. It says if 1 mole of each of the gases involved in this reaction is taken in a 2-liter vessel and Kc for the reaction is 16, find the equilibrium constant concentration of NO and NO2. So now the equilibrium constant is given to us and we are supposed to find out the concentration of one of the reactants and one of the products at equilibrium. Now the reaction is when NO2 gas is reacted with SO2 gas, sulfur dioxide, it forms sulfur trioxide and nitric oxide. Now initial concentration as stated 1 mole, we have 1 mole of all the 4 gases. They were taken together in a 2-liter flask. So the flask volume is 2 liters. Now these are only the moles, remember, this is not a concentration. It will be concentration when we divide this by 2. So it's initial, not concentration, we must write initial moles. Now similarly, let's move further. When the reaction proceeds, we know that SO2 and NO2 will react with each other. They will form SO3 and NO. Their concentration will decrease and the concentration of SO3 and NO will increase. Now, since the coefficients involved are 1, 1, we can easily make out that whatever the number of moles of this will react, the same number of moles of this will also react, and the same number of this will be formed, and the same number of moles of this will also be formed. If, therefore, alpha moles of NO2 has reacted, so concentration at equilibrium, or we can write the moles, equilibrium moles of NO2 will be 1 minus alpha, because alpha has reacted. How much are left? 1 minus alpha. Similarly, definitely alpha moles of SO2 will react. So what will be the moles of SO2 left at equilibrium? It will be 1 minus alpha. And since the alpha moles of these are reacting, alpha moles of these will be formed, and therefore the concentration at equilibrium will be 1 plus alpha, because 1 was initially there, and it also will be 1 plus alpha. And if we want to change them, all these, since remember again, all these are moles, not concentrations. If we want to change them to concentration, we have to divide these moles by the volume, and by V will make it concentration. First write down the Kc expression. It will be SO3 concentration, NO concentration, NO2 concentration, SO2 concentration. It will be, which will be equal to 1 plus alpha upon 2, because it is in 2-liter vessel, upon 1 plus alpha upon 2, 1 minus alpha upon 2, and 1 minus alpha upon 2. And this whole equilibrium constant, this Kc as given, is 16. This 2 gets cancelled. These will become the square. So we can write this 16 as equal to 1 plus alpha square upon 1 minus alpha square. Now we can take the square root of both the sides. This is going to give us 4 equal to 1 plus alpha upon 1 minus alpha. If we open it, we get 4 minus 4 alpha is equal to 1 plus alpha. Bring 4 here, it will become 5 alpha equal to 3, and this will come out to be, alpha will be 3 by 5, so it is 0.6. It means what? 0.6 moles of the SO2 and NO2 has reacted, and 0.6 moles of SO3 and NO are formed at equilibrium. So what is the concentration? Therefore, concentration of NO2, let us find out first. This is NO2 will be 1 minus 0.6, it will be 0.4 moles divided by 2. That will be your concentration. or we can write if the moles, because it is saying find equilibrium concentration. So it will be like this. And if we want to find out the equilibrium concentration of NO, it will be 1 plus 0.6 by 2. So it will be 1.6 by 2. So it will be 0.8 molar. So this is how, and this will be 0.4 by 2 tha. That will be, you are coming out to be, it will be 0.2 molar. So this is how we can easily find out the concentrations of any of the reactants in the products if the equilibrium constant is given to us, and this numerical was again involving the degree of dissociation, which was not given. We have calculated it with the help of the equilibrium constant, and through which we have find out the equilibrium concentrations of the reactants in the product.